Ever wondered how your favorite apps and websites function? It's all thanks to programming, but what exactly is programming? Programming at its core is the process of creating a set of instructions that computers can understand and execute. It's like crafting a recipe for a complex dish. The recipe, or code, tells the computer or chef what to do and when to do it. This code powers everything digital around us, from games and social media platforms to banking systems and weather forecasts. But programming wasn't always as advanced as it is today. It has a rich history that dates back to the mid-20th century. The first programming languages like Fortran and COBOL were developed in the 1950s and 1960s. Since then, hundreds of languages have been created, each with its unique syntax and purpose, contributing to the evolution of technology. Now, you might be wondering, what are some of the key concepts in programming? Well, let's start with variables. Just as in mathematics, a variable in programming is a placeholder for a value. It's like a box that can hold different things at different times. Next up, we have data types. These are the different kinds of values a variable can hold, like numbers, text, or even complex data structures. Then there are loops, which allow us to repeat certain actions until a condition is met. Imagine being able to tell a robot to clean your room until it's spotless. That's what loops do in programming. Finally, we have conditional statements. These are the programming equivalent of making decisions. If it's sunny, go for a picnic. If it's raining, stay indoors. These if-then decisions are a fundamental part of programming logic. Learning programming might seem daunting, but don't worry, there are countless resources available, from online courses and tutorials to books and community forums. Remember, every great programmer started from zero. Stay tuned to start your journey in the captivating world of programming. The first step in your programming journey is choosing a language. But which one should you learn? This is a question that often stumps beginners. Let's demystify this process. To start, let's explore some of the popular programming languages out there. Python, known for its simplicity, is a great beginner-friendly language. It's widely used for web development, automation, and data analysis. Java, on the other hand, is a versatile language popular in enterprise environments. It's the go-to language for Android app development. JavaScript is the backbone of the web, powering interactive elements on websites. Finally, C++ is a powerful language that forms the basis of many modern languages. It's commonly used in system software, game development, and embedded systems. Each of these languages has its unique syntax, use cases, and difficulty levels. Python syntax is clean and easy to grasp. Java and C++, while more complex, offer a strong foundation in object-oriented programming. JavaScript syntax is a bit quirky, but becomes intuitive with practice. So, how do you choose your first programming language? Well, it largely depends on your goals. If you're interested in web development, JavaScript is a must. For data science or automation, Python is your best bet. If you're aiming to develop Android apps, Java will be your companion. And if you want a deep understanding of how computers work, C++ is a good choice. But remember, there's no wrong choice here. The principles of programming remain the same across languages. Once you learn one language, picking up others becomes easier. It's like learning to drive a car. Once you know how to drive one, you can drive them all. For learning resources, there's a plethora of online courses, books, and tutorials available for each language. Websites like Codecademy, Coursera, and Udemy offer comprehensive courses. Books like Head First Java or Learn Python the Hard Way provide in-depth knowledge. And don't forget the wealth of free tutorials on YouTube and blogs. Remember, the best language to learn first is the one that best aligns with your goals. So, take a moment to reflect on what you want to achieve with programming and let that guide your choice. Happy coding! Now that you've chosen your language, it's time to set up your programming environment. First off, let's talk about integrated development environments, often abbreviated as IDEs. These are software applications that provide a comprehensive set of tools for software development. An IDE typically includes a code editor, build automation tools, and a debugger. Some of the most popular IDEs include Visual Studio, Eclipse, and IntelliJ. Setting up an IDE is like setting up a creative workspace. It's where you'll be writing, editing, and debugging your code. Each IDE has its own unique setup process, but generally, you'll need to download the software from the provider's website, install it on your computer, and configure it to your preferences. Now, let's move on to some essential tools and software you'll need for programming. First on our list are compilers. These are special programs that transform source code written in a programming language into another computer language. For example, a Java compiler transforms Java code into bytecode that can be executed by the Java virtual machine. Next, we have debuggers. Debuggers are used to test and debug a program. They let you pause your program at any point to examine current values of variables and the flow of execution. They are a programmer's best friend when it comes to squashing those pesky bugs. Finally, we have version control systems such as Git or SVN. These tools allow multiple people to work on a project at the same time without overwriting each other's changes. They also keep a history of all changes made to the project, making it easy to revert back to a previous version if something goes wrong. Setting up these tools can be as simple as downloading and installing them from their respective websites. However, some of them may require additional configuration to work correctly with your IDE. Remember, each programming language may require a different set of tools and software. So it's important to do a bit of research and find out what you'll need for your chosen language. With your environment ready, you're all set to start writing code. Now it's time to dive into the core of programming. Ready to code? Let's start by unpacking the magic of functions. Think of functions as a black box. You put something in, it does its magic, and out comes a result. Functions help us to structure our code, avoid repetition, and make it more readable. Next up are objects. Objects are like individual superheroes with their own set of powers, or in programming terms, properties and methods. They encapsulate related data and functions into one neat package, making it easier to manage complex code. Then come classes, the blueprints for creating these super objects. A class defines what an object of its type will look like and how it will behave. It's like a blueprint for a house, detailing how many rooms it will have, where the kitchen will be, and so on. Now let's talk about practice. Coding is like learning a new language. The more you practice, the better you get. Try solving coding challenges or building simple apps. This not only helps you understand concepts better, but also gives you a taste of real-world programming. Ever hit a roadblock while coding? That's where debugging comes in. Debugging is the process of finding and fixing errors in your code. It's like being a detective hunting down the culprit that's causing the trouble in your code. Lastly, some best practices. Always aim to write clean and organized code. Think of your code as a story that you're telling your computer. It should be easy to follow, with each line of code serving a purpose. And don't forget comments. They're like footnotes, explaining what each part of your code is doing. They're especially helpful when you're revisiting your code after a long time, or when others are reading your code. Remember, programming is a journey. It's okay to feel overwhelmed at times. What's important is to keep going, keep exploring, keep learning, and most importantly, keep coding. Remember, practice makes perfect. Keep coding. Data structures and algorithms, the backbone of efficient programming. But what are they? Essentially, data structures are the building blocks of programming, the containers that hold data in a way that enables efficient operations. From arrays and lists to stacks and queues, each data structure has its own unique properties and uses. Imagine you're organizing a deck of playing cards. You could stack them, which is similar to a stacked data structure where the last card added is the first one you remove. Or you could lay them out in a line, equating to an array where each card is accessible directly. The way you choose to organize these cards or data can drastically affect how quickly and efficiently you can perform tasks. Now, algorithms are a different beast. They are the procedures or formulas for solving problems. Think of them as the recipes that dictate how to use our data structures to achieve a desired outcome. For instance, sorting algorithms organize data in a particular order, while searching algorithms locate specific data within a structure. Take our deck of cards again. If you want to find the ace of spades, you could look at each card one by one, akin to a linear search algorithm. Alternatively, if the deck is sorted, you could use a binary search algorithm, halving the number of cards you look through each time until you find your ace. The choice of algorithm can significantly influence the speed and efficiency of your code. But don't just take my word for it, give it a try. There are countless coding challenges out there that provide hands-on practice with various data structures and algorithms. And remember, it's not just about finding a solution, but also about analyzing the time and space complexity of your solution. This analysis, often done using Big O notation, is critical in understanding the efficiency of your code. Mastering data structures and algorithms will take you one step closer to becoming a proficient programmer. Ever dreamt of building your own website? It's time to turn that dream into reality. Welcome to the fascinating world of web development, a constantly evolving field that brings your ideas to life on the World Wide Web. Web development is all about creating, building, and maintaining websites. It encompasses several aspects including web design, web content development, and network security configuration, among others. At its heart, web development is rooted in three core languages: HTML, CSS, and JavaScript. HTML, or Hypertext Markup Language, is the backbone of any web page. It's used to structure the content on the page, from text to images and everything in between. It's like the scaffolding of a building, providing a solid structure upon which everything else is built. Next, we have CSS, or Cascading Style Sheets. CSS is all about presentation. It styles your web page, dictating everything from the color of your text to the layout of your content. Think of it as the paint and decorations that make a building visually appealing. Lastly, there's JavaScript, the language that brings your website to life. JavaScript is responsible for the dynamic elements of your site, like interactive forms or animated graphics. It's the electricity that powers the building, making everything functional and interactive. Once you've mastered these three core languages, you can start exploring web frameworks. Frameworks like React, Angular, and Vue help streamline the development process, allowing you to build complex web applications with less code and in less time. They're like the power tools that make constructing a building quicker and more efficient. Now let's put theory into practice. Try building a simple web application. Start with a basic HTML structure, add some CSS for styling, and use JavaScript to make it interactive. Don't worry about perfection. It's all about learning and improving along the way. Congratulations on building your first web app. You're officially on your way to becoming a web developer. Remember, practice makes perfect, so keep building, keep learning, and most importantly, keep having fun. In the age of smartphones, mobile app development skills are in high demand. Ready to build your own app? Mobile app development is a dynamic field, and it's about more than just coding. It's about creating an enjoyable user experience, understanding the needs of mobile users, and leveraging the unique features of mobile devices. There are two leading platforms for mobile app development: iOS, developed by Apple, and Android, developed by Google. These platforms use different programming languages, Swift for iOS and Kotlin for Android, but don't worry. There are frameworks like React Native and Flutter that allow you to write code once and run it on both platforms. React Native, developed by Facebook, allows you to develop native mobile apps using JavaScript and React. It's a good choice if you're already familiar with these technologies. On the other hand, Flutter, developed by Google, uses a language called Dart. Flutter is known for its beautiful UI and fast development cycle thanks to its hot reload feature. Now let's imagine you're building a simple mobile app, perhaps a to-do list app. You'd start by designing the user interface using a combination of built-in widgets. Then you would create functionality for adding and deleting tasks. You would also need to consider how to store these tasks. Would they disappear when the app is closed, or would they be saved to a database? As you work through this process, you'll encounter challenges that will push you to learn and grow as a developer. You'll need to understand the principles of UI/UX design, how to work with data, and how to debug and test your app. Mobile app development also involves understanding and implementing various APIs for things like location services, camera access, or push notifications. This is where the real fun begins, as you can truly start to leverage the capabilities of a mobile device. But remember, building an app is not a one-time thing, it's an iterative process. You build, you test, you deploy, you gather feedback, and then you improve. And there you have it, your very first mobile app. Every app needs to store data, but where does it all go? Databases come to the rescue. They're like digital filing cabinets, storing, managing, and retrieving our data when we need it. There are two primary types of databases, SQL and NoSQL. SQL databases, like MySQL, are structured, reliable, and great for complex queries. On the other hand, NoSQL databases, such as MongoDB, are flexible, scalable, and excellent for handling large volumes of data. Now, where do these databases live? They're hosted on storage solutions. These could be local file systems or in the cloud. Cloud storage is increasingly popular due to its scalability and accessibility. Services like Amazon S3 and Google Cloud Storage offer robust solutions for storing and retrieving data globally. So whether you're developing a blog, an e-commerce site, or a mobile game, understanding databases and storage is essential. With a solid understanding of databases, you can build more complex and interactive apps. Security and testing, two crucial aspects of any software development process. But why are they so important? Let's unravel this. Security in programming is about safeguarding your application from potential threats. Think of it as a lock on your door, keeping unwanted guests out. It involves practices like encryption, where data is transformed into a format that can't be understood without a decryption key, and authentication, verifying the identity of a user before granting access. On the other hand, testing is the process of checking your application for bugs or errors. It's like a health checkup for your app, identifying any issues before they cause problems down the line. This is where testing frameworks like JUnit and PUnit come in handy, helping automate this process. Both security and testing should be integral parts of your development process, not an afterthought. Good security practices protect your app and its users, while thorough testing ensures smooth and reliable operation. Remember, a secure and well-tested app is a reliable app. You've built your app, now what? It's time to talk about deployment and maintenance. Deployment is the process of making your application available for use. The two main strategies are cloud-based and on-premise deployment. Cloud-based deployment leverages the power of internet servers, allowing your app to be accessed anywhere, anytime, while on-premise deployment means installing your app on individual devices or networks. To streamline deployment, there are a plethora of tools available. Docker, for instance, packages your app and its dependencies into a container, while Kubernetes helps manage these containers across multiple machines. But deployment isn't the end of the road. Maintenance is a vital ongoing task. Regular updates and patches are necessary to keep your app secure and up to date. This includes versioning, where each update is given a unique identifier, and backups, which ensure data can be recovered if something goes wrong. Deployment is the final step in your app development journey, but remember, maintenance is an ongoing task. Ready to take your programming skills to the next level? Let's dive into some advanced topics that can really set you apart. Machine learning, for instance, is a fascinating field that's rapidly growing. It's about teaching computers to learn from data, to make predictions or decisions without being explicitly programmed to perform the task. Then there's game development, a creative and technical art form. It's not just about writing code, it's about creating compelling experiences that captivate users. You could be designing the next big indie game or even working on a blockbuster title. And let's not forget about network programming, where you create systems that communicate with each other. It's the backbone of the internet and a crucial part of many businesses today. These are just a few examples of the specialized fields you can explore. Online courses, books, and tutorials can provide you with deeper insights and practice exercises. Don't stop learning. The world of programming is vast and ever-evolving. You've come a long way in your programming journey, but this is just the beginning. From understanding the basics of programming, choosing your first language, setting up your development environment, to mastering programming fundamentals and diving into web and mobile app development. You've explored databases, learned about security and testing, and even peeked into advanced topics like machine learning and artificial intelligence. The road ahead is filled with endless opportunities for growth. Keep learning, keep challenging yourself, take on new coding projects, contribute to open source, join coding communities. These experiences will hone your skills and build your portfolio. As you move forward, remember, there are countless resources out there to help you. Websites, online courses, forums, and books are available to deepen your knowledge. When you're ready to take the plunge into the professional world, job boards and freelance websites are excellent places to start. Keep coding, keep learning, and most importantly, have fun doing it. The world of programming awaits you.